In software engineering, we are discussing chapter number 12, Design Concepts. So design is a very important part of the SDLC, Software Development Lifecycle. We plan, we gather the requirement, and then we do the designing based on the requirement models, analysis models. Before making a house, what we do? We design a house, or making a train network. So we need to design. So software design is all about principles, concepts, and the practices in order to develop a high quality system, a high quality product. Quality, we are going to discuss the quality attribute just now, but it has to be good. Here you see gentleman, he is Mitchell Kepper. So he developed Lotus 123. In early 1990s, Mitch Kepper, who was the creator or who is the creator of Lotus 123, he presented in Dr. Dobbs' journal the Software Design Manifesto. So what does this Software Design Manifesto consist? So he combined various things. He wrote, what is a design? He said there are two worlds. One is the world of technology. One is the world of what we have, the advancement, the technological advancement, and the other is human. What human want, what are their purpose? So the software design is all about combining these two worlds together. He also mentioned that the Roman architecture critic Vitruvius, he said well, that in order to say that a building is designed well or this building has a good design, that building has to exhibit, has to show certain features. What are these features? Like pyramid, like the leaning pizza. Firmness, that is, it has to be stout, commodity, it needs to be used for some purpose. And delight, we become very happy when we use it. And he said that the same thing is true with a good software, if you are regarding it as a good software. So firmness is all about the error and the bugs. So the program should not have any bugs that will inhibit the functionality. That is, there should not be any bugs. Commodity means for the purpose it was being developed, it should be used. It is suitable for the purposes for which it was intended or made for. Commodity. For example, the earplugs. Now they are very important and they should solve the purpose for what they are being built or they are being manufactured. So software is a kind of commodity also. Delight is all about experience. You should feel good and you want to use it again and again. So in order to accomplish firmness, commodity, and delight, there are two things which we need to practice as a software people. Diversification and then the convergence. Now these two words seems to be very different, but you'll just know diversification is all about thinking in different perspective, using in different perspective, and then finally finding out the best and then converging them. Here you see Laszlo Belady. What he said? Now he mentioned that diversification is acquisition of a collection of alternatives, the raw material of design, components, component solutions and knowledge, all contained in catalogs, textbooks and the mind. So you can go to Kerala, you can go to say Kentucky. What is your alternative? So you are deciding the alternative. And what do you need in order to make, say, rice? You just need water. But in order to make a good rice, you want to put some pea in that, some ghee in that. So the raw material. And if the component means those already built part or software or code that can be reused. And at least you should have all the knowledge and the catalog that this all is in the list. And that list will only come when you read and when you think. So what all alternatives are there, what all possibilities are there of the component, what are the knowledge we can impart, what are the, all those things should be in your chart, that is catalog. So now we have everything that is from the repertoire or the catalog. We pick and choose the element because what we are choosing has to meet the requirements. Because what you have done previously, you have done the requirement engineering and the analysis model. So whatever you choose here has to have some link or the backlink to the requirement models, the requirement engineering. That is how we pick and choose from all what we have chosen. This is the diversification and the convergence in order to accomplish the firmness, commodity and delight. So after that, what we do? Because we have chosen or we have thought about all the alternatives. Now what alternatives have to be chosen and what alternatives have to be rejected? That is, we are getting to what configuration we want of the component. For example, we want payment gateway, we want calculator that has to be put for the final product. So diversification and convergence, they come from intuition, they come from judgment. That is, you know what you're doing is correct or somewhat incorrect. And then you have the judgment because all the knowledge you have gained, what I'm giving you also, these are based on what? Experience. If you've already built the entities, if you've already built the same kind of software, you have the experience. And the set of principles and the heuristics that evolves model. The principle to make a certain software may be different from the principle and heuristics. Heuristic is all the hidden trial and the thoughtfulness. That will make a software design evolve. So experience along with the underlying principles and criteria that enables quality to be judged. Because this is all about quality. If a good product is there, its quality will be good. So what are the quality that will enable quality to be judged? You need to validate, you need to verify also. And finally, the iteration. Iteration means not just making design at once, making it again and again so that it leads to the final design that can be used for coding and maintenance testing. So this is the iterative process. You need to have experience, principle and the judgment for the quality. Now this diagram is very important. This is the actually underlying diagram of what we are going to discuss. So software design can be applied or has to be applied everywhere. That means what software design is to a software development is that it is applied regardless of any software process model you choose. You say I am choosing waterfall, some say spiral, some say agile. In agile especially I am going to use the Scrum. Whichever software process model you use, software design has to be applied. This is very important. So once you have done the software requirement part, that is you have analyzed and they made some models like the use case models, state diagrams and the class diagrams, etc. We've already done this part, software requirement. Now the next process is software design. So software design comes under this modeling activity only. So you can regard software design as the last software engineering action where you do the modeling, because already software modeling you have done, requirement modeling, and this software design is also a modeling. You can say it's a last software engineering modeling process, because now you have created the models for software and now you are set for construction, that is actual coding and then testing. The code generation will only be fruitful when you have a good software design. Now this diagram is very important. Let me tell you, because all other content depends on this. In design model, first thing is component level design. That is what all component. For example, as I said, you are making some e-commerce website. You have to give a payment gateway. Payment gateway is component level design. Interface, how user interact. Architectural design, that is how the different components and the system parts are going to interact, how they are being placed. And the data in the class diagram, because here you are going to make actual class and what are the data structure you are going to use. This is the design model. So from where all these are coming, we have already done the requirement analysis model. So in scenario based, we have used the use case diagram, we have made the activity swim lane. In behavioral, we have made state diagram, sequence diagram. In class based elements, we have made the class diagrams, analysis packages, CRC models, and the collaboration diagrams. So this all you will make in UML, Unified Modeling Language, and now you are ready for the design. So for component level design, it will come from where? It will come from the scenario based elements, the behavioral elements, as well as the class based elements. It will interface design. From where it is going to come? It will come from the scenario based element, for example, use case diagram, and the behavioral elements like the state diagrams and the sequence diagram. Because how user going to interact? These are the inputs for the interface design. Architectural design, what is the input? The input will come from the class based elements. In data and class design, again, the input will come from the class based elements. So class based element is very important as far as the analysis modeling is concerned. So as I said, design will do what? Design will produce data structure, class, and architecture, and interface, the component design. So this is a triangle what you see here. The design will produce all these: component level design, interface design, architectural design, and the data class design. So the input is of course the requirement engineering and the requirement model. So the data class design, the lower part of the triangle you see, it transforms the class model into design class realization, then the data structures required to implement the software. So this is all about, you have already made the models, now you are going to realize it, to implement it, to show the coder how to actually implement it. And the data structure, you want to use the say structure or say a linked list. The object and the relationship defined in this CRC diagram and the data content depicted by the class, these are the basis for the data and class design. As I said, this is the input. Coming to the second part of this triangle, the architectural design, it defines what? It defines the relationship between the major structural elements. Architecture is all about major structural elements. What are the architectural styles you are going to use, and the pattern already you have used or made in certain other software, you can use it here. And also in the constraints, this is the paridhi, this is the boundary. The architectural design is actually the framework of the software, and from where it is derived, it comes from the requirements model. This is the architectural design, basically the software framework. Okay, how this software will be made, what are the parts, how they're going to interact, the different components for the different part of the system. The interface design describes how software will communicate with the system which it is going to interoperate with. Because software may be working with, say, database, some networking, some TCP, IP here and there. So it has to interoperate. And along with the human, these are the main key parts. So an interface implies a flow of information, that is how the data is flowing, how the control is flowing. It is all about the behavior, how the software is going to behave for each action, the snapshot. Then comes the input, usage scenarios and the behavioral models, basis. These are the basis for the interface design. Okay, so these all scenario, behavioral, class based, they all are giving The component level design, the topmost part of the triangle, this design transforms the structural elements of the software architecture into the procedural description of software components. Now, previously you have defined, but now you have to give the procedural description. What are the procedure, what are going to be implemented, because the next part is directly coding. So you have to prepare these things for the coding. Why is software design so important? Why are we talking about it? The answer is quality, gunavatta. If quality is not good, any product you use, you will not use it next time. So design is giving you a representation of the software that can be assessed for quality and that can be checked for quality and that represent and that correspond or inherit or nurture the quality. The design is the only way, this is the only way to actually translate and convert the requirements into a proper software. Without designing, what are you doing? You are making a software which is unstable. You're making a system you cannot rely upon. You're making an unstable system. A system which will fail. Whatever small changes you make, it fails. You will not be able to test it. The testing will be so difficult. And the quality cannot be assessed until the software is complete. So you are building an unstable system without design. So software design is an iterative process. Again and again we go. Because you have a requirement model. Now, requirement model you have to translate into the construction. That is actually coding. So what is in between? Your requirement you cannot directly code. You have to have a design that is the core or the underlying idea actually to be coded. Because the coder will say design, and design if properly made, coder will have no problem in the coding. So software design principles include the problem partitioning, modularity, the different strategies like top down and bottom up, and finally the abstraction. As I said, these are iterative process. So initially the blueprint, the initial process, it will show the high level of abstraction. That is, what is the system objective, the functional and the behavioral requirements, all these needs to be shown in the high level of abstraction, in the software design. Then comes what? The low level of abstraction. That is, now you are going to show the use case scenario, the actual requirements. So the requirements and the low level of abstraction, they need to be traced. So they are different level of abstraction. Software quality guidelines and attributes. Now McGraw-Hill, he suggested 3 important characteristic goals in order to evaluate a good design. What is a good design? A design which implement all the explicit requirements, those requirements which are being set properly to you in the requirement model. What are there in the requirement model? Along with this, the stakeholder that they have not conveyed, that is the implicit requirements, the quality requirements has to be there. The design should be clearly readable in good notation, understandable. It should be a guide for the coders, for the programmers, and the people who are going to maintain it, the maintainers. The design should clearly, specifically, efficiently address the data, functional and behavioral domains for implementation. As I said, design is the precursor for actual implementation. How to achieve these goals? The McGraw-Hill goals, how to do that? For that, there are software quality guidelines. Here see certain points I have already given. A design should exhibit an architecture. What should that architecture contain? All architectural styles and patterns. That is what already is being done, you can use it, and different architecture style that suits that software. Has components, that is, as I said, payment gateway or some other already code, it should be having good design, and it should facilitate implementation and testing. Because when you design, it should just flow into the coding. A design should be modular. That is, dividing a whole problem into logical division. The software should be logically partitioned into different elements, independent elements and subsystems, and then they can be addressed. The design should be properly modular so that it can be understood well, it can be coded well. Design should contain distinct representation of data, architecture, interfaces and the component. The design should lead to appropriate data structure. There should not be any anomaly, whether you should use structure or linked list. A design should lead to components that exhibit independent functional characteristics. That means the functional characteristic, as we have logically defined and partitioned, every function should be clear. A design should lead to interfaces that reduce the complexity of connection between component and external requirement. You are using component, you are interacting with the external requirement, the environment. The interconnection should be easy, the coupling, the cohesiveness. A design should be derived from where? From requirement. So it has to come from software requirement analysis, the models you have made in the analysis model while you are actually doing the requirement engineering. A design should be represented using effective notation, that is proper way, readable, understandable. The notation has to be very clear so that it can be understood by the programmer and then the tester. Software quality attributes. Now HP, HP is a giant. So this company has developed a set of software quality attributes. The acronym is FERPS. So these software quality attributes combine, and in these few, five first letters, it defines the whole software design and what do we expect from a software as far as our point of view is quality. So F is functionality, U is usability, R is reliability, P is performance, and S is supportability. What is functionality? All the features and the functionalities and the capabilities. The functionality is assessed by evaluating all these. And along with the security, if your system or software is based on security or it needs security, this also comes under functionality. Usability, that is when I am going to use it, the aesthetics, the view, consistency, one thing is there, the other should be like that only. The documentation, like the user guide, like the help, this is called usability. The reliability is evaluated by measuring what? The failure. How many times the failure is happening, the frequency of failure, how severe is the failure, how much the result you can rely upon, accuracy of the output result. What is the mean time to failure? What is the mean time between failure? What is the ability to recover from failure? The performance is, what is the processing speed, response time, how much resource this system is consuming, how much throughput we have, what is the efficiency of the software as we are going to use it on some system or computer. So all these comes under performance. The supportability. So you can combine all these three, the extensibility, adaptability and serviceability. What I'm saying here is that this software has to be supported. Once you have delivered the software, deployed the software, someone has to be maintaining that software. That is supportability. That comes to extensibility. If you change, that is all change management. The software needs to adapt to different scenarios. It needs to be serviced. So these three attributes, these comes under maintainability. As I said, this all comes under the software maintenance part. And testability, compatibility, configurability, ease of installation, ease to localize the problems. This is that the software needs to be testable. Compatibility means different configuration, different you can say the operating system, it should work. Configurable means you need to have a compile guide. It should be configurable. You may be able to change it depending upon the situation. Okay, this is the first part of this discussion. We'll be taking a few more of these. Thank you so much.